Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be simplifying a complex expression. We have 3 minus I divided by 1 plus I plus 8 plus 5i divided by 1 minus I. And we're going to simplify this expression and write the answer in standard form. I'm going to try to introduce a couple different methods here, even though there aren't that many. I'll still talk about, some alternatives. Now, I want to start with the question. Should we make a common denominator or multiply by the conjugates? Think about it for a second. And the answer is, it doesn't matter, at least for this problem. Why? Because it's the same thing. 1 plus I and 1 minus I are already conjugates. But think about a situation where they are not, so you would have two alternatives. Anyways, so let's go ahead and multiply by 1 minus I and 1 plus I. Let's go ahead and distribute. 3 minus I will be multiplied by 1 minus I, and 8 plus 5i will be multiplied by 1 plus I, and all of that will be multiplied by 1 plus I times 1 minus I. Do you remember when we multiply two conjugates, we always get a real number, and that was always sum of two squares, which is 1 plus 1. Remember that? So it's going to give you 2. Great. Now, let's go ahead and distribute and simplify the numerator. It's going to give us 3 minus 3i minus I plus I squared, which is negative 1, plus 8 plus 8i plus 5i plus 5i squared, which is minus 5, divided by 2. All right? Great. Now, what do we do next? Simplify. Let's do it. 3 minus 1 is 2. 2 plus 8 is 10. 10 minus 5 is 5. If I didn't make any mistakes, that's a 5. And now we have a negative 4i plus 4i and a plus 9i. And all of that is divided by 2. Now, obviously, you can write this answer in standard form as 5 over 2 plus 9 over 2i. Of course, that's the standard form because we're supposed to write it as a plus bi, right? All right, great. So that's one way to approach it. Now, is there an alternative for this kind of problem? Let's go ahead and take a look. 3 minus I divided by 1 plus I, and then 8 plus 5i divided by 1 minus I. Okay, cool. Could we get away without multiplying by conjugates or making a common denominator, which is the same thing in this case? Well, one method I can think of is use the polar forms. But here's the problem. Turning these numbers into polar forms will be kind of painful. The denominators are fine, but think about 3 minus I. Let's go ahead and attempt it. So if z is equal to 3 minus I, let's go ahead and find the r modulus, which is absolute value of z. That will be square root of 10, right? Square root of a squared plus b squared. And then tangent theta would be negative 1/3. And if you write z as follows, so take the square root of 10 out, and then inside you're going to have 3 over square root of 10 minus 1 over square root of 10i. Now, when you take out the r from a number, this is what happens. Think about it. Whenever you had a number like a plus bi, and then you took out the absolute value of a, right? You took out the square root of a squared plus b squared, and inside you had a over the square root of a squared b squared plus b over the square root of a squared plus b squared I. Now, this becomes the cosine of theta, and this becomes the sine of theta. And of course, that's where the tangent comes from. If you divide those, you're always going to get tangent theta, which is kind of y over x, okay, in polar coordinates. So we have an angle whose cosine is this and whose sine is this. So cosine is positive, sine is negative. The problem is you got to find the angle, but that's not a special angle. You can kind of write it this way too. You can say, hey, if cosine theta is equal to 3 over square root of 10, then theta should be arc cosine of 3 over 10. Some people are going to write this as cosine inverse, not arc cosine. Some people use the arc notation. If you ask me, honestly, I like the arc notation better, but in the United States, I believe cosine to the power -1 is more common. The problem with that is it could be misinterpreted as the reciprocal, but the reciprocal of cosine is secant, so if you have 1 over cosine, always write it as secant, not cosine to the power -1. Or you can put it outside the parentheses. Anyways, but since this is not a special angle, you can leave the theta like that, and then you can find another angle for this. See how painful that is? That's why sometimes working in standard forms is a lot easier. But think about a different scenario where you had something like this. 3 minus I over 1 plus I. Let me just make up a problem real quick. We're not going to solve it, but I just want to show you what would happen in this case. Now, here's the $1,000,000 question. Would you make a common denominator or multiply by the conjugates? And which one is better? Okay. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.